Welcome back. In this video, we're going to take a look at the derivative of the general exponentials and logarithmic functions. We don't use these a ton, but I wanted to go through it with you anyways. If you take the derivative of a general exponential, where this is like a 3 or a 2 or a 10 or something like that, to the x power, it's the original equation times the ln of the base. We don't have to include that ln of the base when we have e because the ln of e is 1. If we throw a function on there, like a to the u, the derivative is going to be the original equation times the ln of the base times the derivative of the exponent. In my first example, the derivative dy dx is going to be the original equation, 10 to the x squared plus 1, times the ln of 10, times the derivative of the exponent, which is 2x. Can't simplify that at all, just leave it that way. If I get into general logarithmic functions, now I take the derivative of the log base, say 2 of x, it's going to be 1 over the ln of the base times 1 over x. This is just like the derivative of ln, but again, the derivative of ln would be 1 over the ln of the base, which would be e, which would just be 1, so we don't write it. If we put a function there with u, we just have to make sure we multiply by the derivative of that function. So it's 1 over the ln of the base times 1 over the original function times the derivative of that original function. The property of log still applies, so like in this problem, before I find the derivative, I'm going to pull 1/3 out front because this is cube root. So pull 1/3 out front and write it as y equals 1/3 times the log base 2 of x squared plus 2x plus 1. Now find the derivative of that, dy dx. The 1/3 would stay, so it's going to be 1/3 times 1 over the ln of the base, which is 2, times 1 over the original equation, which is x squared plus 2x plus 1, times the derivative of that equation, which is going to be 2x plus 2. A couple of things, you can write it out all as one fraction, like dy dx. You would see this answer written this way would be 2x plus 2, and then it would be 3 ln of 2 times x squared plus 2x plus 1. And the only one little trick that we could throw in is this 3 is technically an exponent on the 2. So the ln of 2 cubed would be 8. So I could write it this way. I could write it as 2x plus 2. And then on the bottom write it as the ln of 8 times x squared plus 2x plus 1. And then at the end of this unit, or at the end of this assignment, you're going to run into some problems where you have to use some logarithmic differentiation. And what I mean by logarithmic differentiation, and you only apply this when you have something that has a variable in the base and a variable in the exponent. So I have an x in the base and I have an x in the exponent. Then I'm going to apply logarithmic differentiation. To do this, what I'm going to do is I'm going to take the natural log of both sides of the equation. So I'm going to write it as the ln of y equals the ln of x times the sine of x. And the reason why I do that first step is then this sine of x, because it's in the power, I'm taking the natural log, I can pull that out front. So I can rewrite it as the ln of y equals the sine of x times the ln of x. Now when I go to take this derivative, on the left-hand side I have to implicitly differentiate it because I have this ln of y. So it's going to be 1 over y times dy dx. And on the right-hand side I have to use product rule. So it's going to be cosine of x times ln of x plus sine of x over x. And then finally I want to solve it for dy dx. I'm going to multiply both sides by y. So dy dx equals y times cosine of x ln of x plus sine of x over x. And then the one last little trick that we're going to do, and not really a trick, but we want the derivative all based upon x. So I'm going to take that y right there, and I'm going to replace it with what it equals in the original equation, which is x sine of x. So ultimately, I would write the answer this way: x sine of x times cosine of x times the ln of x plus sine of x over x. Remember, with that logarithmic differentiation, you're only going to do this when you have something that has a variable in the base and a variable in the exponent. All right, so just memorize these derivative patterns. I'll talk to you back in class, and we'll get some clarification on any misunderstandings you might have.